So this is the first of 3 activities on 3D imaging. Shape from stereo. Our objective is 1, to align 2 images of a scene along their epipolar line. I'll explain epipolar in a bit. Find matching points 2, in a scene pair using feature matching algorithms. And 3, derive depth information from image disparity. Now, the idea behind stereometry is very simple. The reason why we can estimate depth is because we have 2 eyes. If one of your eye gets injured and you can only see with one eye, it's very hard to determine if a scene is near or far. It's hard to estimate or gauge depth. Now, how far a scene point is from a camera can be estimated using 2 images of the same scene taken by the same camera. The second image should be taken at a short displacement from the original position of the camera. Now, alternatively, the scene can be captured by 2 identical cameras spaced slightly apart, just like our eyes, 2 cameras. This estimated distance from the camera is referred to as range or depth in 3D imaging. Now consider the diagram below. So here you have 2 identical cameras. They each have focal lengths f, and they are placed a distance b apart. A scene point, red dot here, is at a range z from the cameras. If we use the line, the z line from the left camera as the origin of the x-axis, this scene point here is a distance L from the x-axis origin. Now, when each of these cameras take a picture of the red dot, measuring its distance from some origin, we see that for camera 1, it sees a distance of x1. See from this ray here, it intercepts the image plane at this point, and the distance is x1. Meanwhile, on camera 2, it sees a distance of x2, right? So you can try this with your eyes. Look at an object with both your eyes open, and then cover one eye, still looking at the object, and then cover the other eye. You notice that there's a shift in the location of the object, diba? Now, the red dot, as I said, the red dot is seen to be at the distance x1 for the left camera and x2 for the right camera. Now, for the derivation, please remember these triangles here and a similar triangle here. We see another triangle here, a large one, and a similar triangle formed here. Okay. By similar triangles, we see that L over Z is equal to x1 over f. Equivalently, we see that L minus V over Z is equal to x2 over f. And substituting L equals Zx1 over f from here and over here, and solving for C, we find that C is equal to Bf over x1 minus x2. B and f are known because you are the one who displays the camera. F is known because it's the focus of the camera. X1 and x2 can be determined from scene points on the image. The term x1 minus x2 is known as disparity. The larger the disparity, the nearer the point. Well, the smaller the disparity, the farther the point. Now, 2 conditions must be met to reconstruct the scene in 3D. Both cameras must have their y-axis aligned. If we will use only one camera, then the f is the same, focus is the same camera. We must move the camera through a measured distance b. If at the second position, the camera was rotated accidentally, the second scene must be transformed to align with the first. There is a line that exists between these 2 cameras based on the scenes that they see. And this is called the epipolar line. Both images must align along that epipolar line. Now, second, we must have estimates of the depth C or the range C for many points on the scene if we want to make a reconstruction of the surface of the scene. I've given this activity before, a version of this activity before in my 187 class. In that activity, I asked them to take a picture of a scene using their cameras, smartphone cameras, or any camera they have. And I asked them to manually align the two images such that their y-axis are the same. Then I asked them to click points that match in both scenes and measure the disparity, okay, or the difference between the x locations of points in the scene, and to do so for many points on the surface of the object that they're looking at. In this version of activity, we will use functions that exist in MATLAB's computer vision toolbox to automate the process for us. As I said, we can use functions in MATLAB's computer vision toolbox to satisfy these two conditions, this alignment of the scene and the sampling of the points to get the disparity. Given matching points in both scenes, we can compute what is known as the fundamental matrix, which relates the transformation of points in the first scene to the second. We can then use the estimated fundamental matrix to align both scenes. Think of the fundamental matrix as a transformation matrix. Diba? May rotation, may translation, may scaling. So imagine mo, may dalawa kang picture of the same scenes and you can see some points on the scene. Of course, you can see the matching points in the scene. Oh, this is the corner of the box. It's seen here. That same corner is seen here in the other image. Now, if you have many points of those matches like that, you can actually compute the fundamental matrix. And from the fundamental matrix, you can reverse the transformation or force a transformation such that they will align. Okay. So, in this first part where you need to estimate the fundamental matrix, you need to find matching points. It can be done manually, but it can also be done automatically. Now, just like PCA, FFT, there is well-established local feature detector in most scientific software or programming language that do computer vision. And these are called local feature detectors. An example of which is the SURF, or the speeded up robust features, or the SIFT, or the scale invariant feature transform. Okay, so what they do is when they look at the scene, they take a feature, they extract features in a scale invariant way, meaning kahit maliit, or rather mas maliit yung isang image kaysa dun sa second image, these features are scale invariant. They look for edges. These feature detectors look for edges and other straight lines and edges and other texture-like features. Okay, so we will use them. We'll not go deeply into them, but use them as a tool. Okay. Now, the procedure for the activity is this. Now I know you each have a smartphone, so assemble a scene where you have a colorful textured object. No, take a picture of that using your camera. And kindly please remember to turn off the autofocus to avoid changing Fs, because we'll assume the F is fixed. No? It's important that you have a colorful textured object. It's hard to find matches, automatically find matches, if your object is just a plain color. So the more design or patterns in your object, the better. Okay. So for example, don't just put on, don't just image a box. Make sure that the box has several labels. No. So yun yung hahanapan nyo ng match. No. Don't just use a plain box. Okay. Yeah. Now move your camera horizontally by 1 or 2 centimeters and retake the picture of the object, and make sure to measure the camera displacement accurately, please. Now, here are the steps. No, you load the 2 images in MATLAB and convert the gray. The SIFT will, or the SURF will work on the gray images. Find the matching points and estimate the fundamental matrix from these matching points. Now rectify and align both images using the fundamental matrix. Then compute the disparity from each point on the image. Then finally compute the depth from the disparity map. Now, for your benefit, I sent you a code for the activity, and all you have to do is just go through the code, try to understand, learn more about the functions, and apply your image. I'll stop share muna dito, and I'll open up my MATLAB online. Yes, we can do this on MATLAB online. What do you see?
Ayan po, ma'am.
Okay, thank you, thank you. May tanong si Marco, ano ba yung kung mag-measure, tama ba? Ano ba sabi mo sa dyan? Ma'am, yung sa pag-move ng camera, dapat po ba sukatin yung sa edge ng smartphone? Just use the same, same reference. If you measure the distance, displacement from the edge of the smartphone, use the same reference. Do you understand? So, pag minove mo, doon mo rin i-base yung ruler from, right? Kasi anyway, yung gitna ng lente, pareho lang naman yung distance from the edge of the phone, right? So, whatever reference edge you use on your phone, it will keep the same distance. Okay? All right. Okay, so kanina I tried, by the way, full disclosure, these sections were lifted from an example I saw, which is the uncalibrated stereo rectification example. It's this. So looking around, I saw this text, this code, and I just copied parts of the code here. To learn more, actually, there are many examples on the web and on the MATLAB documentation. Here are more. No? So, for example, this is one where you can estimate from video. Look at this. This is like an anaglyph. Yung 3D na image na you show the two scenes side by side. No? And there are actually more. Mamaya tingnan natin. Compute disparity map. Here's another. So again, another scene taken from two cameras. As you can see, the disparity is clear here. So linagay lang siya side by side. Okay, let's go. So kanina, nagkuha ako ng picture ng keyboard ko and I uploaded it on my MATLAB drive. And here it is, Stereometry. So let's go through this, shall we? So first, load the image and convert to grayscale. My editor. Let's run this section. Hindi niya papakita yan. It just loads and converts it to gray. No? Now, find matching points. So here, you could use surf. So the text surf features will look for 2,000 matching points. Or rather, or features. Features muna, tsaka yun matching. Okay? Alright. Dito yun matching. Dito muna yung calculate ng mga features. Okay, so let's go through that. 2,000 yung hahanapin niya and then ima-match niya. Okay, let's go through this section. Okay, running this section. You'll see it's going through the lines here. It will show my keyboard, the two images of the keyboard. And you see here, lalaki kaya. You see here the points, the matching points that have been seen. No? You can see the disparity na from here, no? Pero hindi pa to aligned. Now there are outliers like this. Most of them seem to have the same direction, but there are outliers. Marami sa kanila pareho ang direction at pareho yung length. Siyempre, di ba, inurong ko lang ng same distance, ay ng small distance. Pero yung outliers pa rin like this. Parang sobrang haba nung nakita niya, no? Ito rin. Now, pangit tong sample na to. Tignan nyo, wala siyang nakitang matches dito sa plane surface ng MacBook. Pero marami siyang nakita ng match doon sa keyboard kasi medyo unique yung mga pattern sa keyboard. So, ano yan just make sure na either maraming patterns, maraming design yung 3D object nyo. for matching. Tingnan nyo, kahit nga yung sa sa table, wala siya nakitang match kasi medyo plain lang yung table. Trackpad at saka sa surface ng MacBook wala, pero sa keyboard marami. Okay? Now, having seen match points, no? So these are the match points that it saw. The next is from there ka-calculate na yung fundamental matrix. Okay? Hanap siya. So let's try this. Run section. Essentially, hanapin niya yung epipolar line as well. Okay? And tatanggalin niya na rin yung mga outliers doon sa matches. Okay? Now, in the end, ito na lang yung mga natirang points na sa tingin niya ay consistent. Okay? Ang mukha naman, ano? And makakalculate na siya ng epipolar line from there. Okay? Or ginagamit niya yung epipolar constraint to leave out or leave in, the matching points, okay, that satisfy an epipolar constraint. Now that we have an estimate of the fundamental matrix, i-rectify na natin yung object. I-transform natin tong object, yung scenes, para yung y-axis nila align. There might be a transformation that would be needed. So watch how the scene transforms, ano? So let's do this now. Let's run this section. Run section. Takes a moment. Okay, angat ko na to in anticipation. Dapat may background music tayo, no? Kumusta kayo, guys? Ako nagko-compute siya. Compute pa siya. Busy pa siya. How are you guys? Kumusta ang inyong mental health? Kumusta ang inyong mga puso? No reacts? Uy.
Malungkot po, ma'am.
Oh, yeah.
Lungkot po since Monday evening. Nakakawala po ng motivation mag-work on everything.
True, di ba? Oo.
Same.
Puyat-puyat ba kayo dyan? Tara, sinong nandito sa Quezon City? Gabi-gabi kakain kami sa labas. Sino gayaya ako? Ililibre ko kayo ng kumi.
Nasa
Nasaan
province
kayo?
ako, ma'am eh.
Ay, sorry ka na
Opo.
lang.
Nasa Rizal po ako.
Okay lang yan, guys. Tinitest ang ating fortitude. Teka, tapos na ba to? Mag-i-aim show pa to. Wait lang ha, baka hindi pa. Busy pa. Busy pa ba, bes? Mukhang busy pa eh. Dapat mag-i-aim show siya. Wait lang ha. Yun! Ay! Saan siya? It takes a moment. Ito kanina. Sinasabi ko nga never mind, it's well, let's accept the result. It's part of it. But that doesn't mean we will stop all our volunteerism after the elections, no? Kayo ba ay nag-attend ng mga mga rallies? Ay, pasintabi sa mga BBM ha. Congratulations sa inyo. Pero ito ay directed sa mga mga Lenny.
Nung Friday po, ma'am, umattend po ako sa home to home.
Uy, pagpalaing kayo. Thank you.
Nag-volunteer po
Yes,
ako
po.
sa town namin. Though di na ako nakasama sa house to house.
Thank you so much. Pero na-feel nyo yung energy, di ba? Ha? Sa mga kapwa nyo volunteers or rallyists.
Yes po, ma'am.
Yes,
Oh,
ma'am.
yun,
Super.
yun. Sustain that. I mean, sarap yun di ba? So, don't forget that.
Mm. Actually po, ma'am, first time na house to house ko po yung Friday. And yun po, ang dami ko pong nakita and natutunan din po. So, parang medyo nagsisi din ako bakit late na po akong pero okay lang naman. No regrets pa rin.
Okay. Buti na lang hindi this is not seen as something red taggable. But in fairness dun sa mga aktivista even before parang ito ginagawa na nila. Di ba?
Yes po.
Yes, ma'am. Sana
Pero,
magtuloy-tuloy.
Mabang
battle pa to.
Pero marami namang ano ba, hey, ang dami ko ng speech dito pero wala pang lumalabas. But what I'm saying is like si Non yung community pantry, that kind of volunteerism, di ba? Yung sharing and all. Hindi lang sharing ng food, sharing ng stories, sharing ng ideas, volunteering your time, energy, all for love and betterment of our countrymen. So don't lose hope. Hang on to that special feeling and then keep on going. Umpisa pa lang to, sabi nila. Dapat may lumabas na image dito, Bay. Meron na dapat dito. Kasi exciting na yung susunod, disparity map. Ito na yung i-inverse mo lang, makukuha mo na yung depth. Ngayon, parang may lumalabas na dapat dito. Huy, pakita ka. Kanina na-try ko to, gumana na to. But, something is happening. Bakit wala? Bookmark ko lang to. Teka ha, baka it's taking some time. But guys, try nyo to, no? Try nyo lang to. In the end, kapag magdi-disparity map, I'm sorry, it's taking a while, but let me show you examples of, well, the disparity maps. This is an example of a disparity map from this rectified scene. Okay? All right. Naglip siya yung parang maroon and cyan naka-display side by side. Tapos, disparity map, hindi pa siya depth map, but it's proportional, right? So, you can see di ba? Pag disparity kasi, the smaller the disparity, kasi inverse, di ba? Z is equal to PF over disparity. Disparity is x1 minus x2. So the smaller the disparity, the farther away the object is. So tama nga naman. Kasi dun sa corridor na yon, tingnan naman, di ba? Mas malayo yung tao. Tapos pag mas mataas yung disparity values, ibig sabihin mas malapit sa camera. Tama nga naman. Kasi itong dingding na to, malapit na sa camera. Right? So disparity to. So kukompute nyo pa yung 1 over disparity para makuha nyo yung depth. But may paraan para i-display na rin actually ito in the scene. Okay, like this. Okay, itong technique na to na stereometry or estimation ng depth or XYZ position ng points on the scene using stereometry ay ginagamit na matagal na ginagamit to. Technology concept na to matagal na. So much so that sa mga maps, sa pag-survey, sa pagkuha ng elevation ng mga mountains, ito yung ginagamit. In fact, yung mga, teka, silipin muna natin before I go on. Wala pa, bakit? Pero tapos na siya. Hindi siya nag-show up. Teka. Dapat mag-show up siya dito. Teka ha? Meron na daw ayaw na lang pakita sa open figure. Alam niyo ba guys, kasi di ba, ayun! Ayan na. Bes, ito na. Yan na. Rectified na to sa lagay na to. Kita niyo yon, yung parang inalign niya. So, notice here, dun sa isa ha, itong sa dito banda. Up. Di ba tagilid pa to? So, pag i-align niya na, it will make sure that the epipolar line is along the horizontal and all points along the y-axis are aligned. So you can see here, renotate niya yung dalawang image and it made sure na align nga. Okay? Alright. Sige, bago
Ma'am,
lahat.
question po. So, yung ibig sabihin po ng pag nire-rectify mo po yung image, bale yung mga parang inalign mo po sa horizontal, like yung mga yellow lines po na
Yes,
nakaslant
yes.
siya.
Yes.
Okay po.
Oo. So all their y-axis points, yung position ng mga, ay hindi, di ba bawat point sa image may x and y position, di ba?
Yes
Bawat
po.
pixel. Ini-ensure nitong rectification portion na ito na yung y position ng bawat pixel ay pareho. Okay? Nagkakaiba lang dun sa x kasi nga disparity. Okay? Alright.
Apo.
Let's hope this works. Okay, so meron na tayong ganito. Remember, yung mga matching points lang ay doon sa may pattern. Sorry, wala dito kasi napaka-plain. No? So, try natin. Sige, tingnan natin kung ano itsura ng disparity. Ito na. This is it. Cross section. Click. Okay, huwag kayong madismaya kung makita nyo. No? Kasi maraming not a number ang lalabas dyan dahil nga yung mga matches doon lang sa keyboard. So, we should get, may error ba? Dapat ito to. So, ibig sabihin nito, it's running, it's computing the disparity map. We'll go through these lines one by one. It's taking some time. Well, that's going on. Ang sinasabi ko is, alam nyo ba yung pag-estimate ng mga bundok sa Moon and Mars, ito rin ang ginagamit itong idea rin na to. Na if you have a camera, actually, if you have a camera and you take a video of a scene while moving, you can actually reconstruct the 3D of the scene. Ganun na nga, kunyari may satellite ka across the Earth. Kaya nga may 3D ng mga mountains and even some other structures. Dahil the satellite takes pictures on one position, it moves a little bit and then takes another picture. Since there is a overlap between the two pictures, you can estimate the depth from the disparity, the two pictures taken by a satellite. Kaya yun na nga, Google Earth can estimate the elevation of a scene. So ganito lang yung ginagawa sa pag-estimate ng or sa pag 3D ng moon surface at saka ng Mars surface. Okay? Same idea. Two scenes taken by the same camera. Since gumagalaw yung satellite, kuha ka ng isa pang capture. Okay, same camera. Okay, it's still running, so it's taking a while. Bitawan muna natin siya. Again, you can check out kasi of course, you will take a look at these functions. If you're using Python, you might want to find the equivalent yan sa OpenCV via Python. Okay, but here are many examples whereby you can use this technique of stereometry in this case. Oh, by the way, ito rin ginagamit sa mga cars, sa mga self-driving cars. Gumagamit din ng LiDAR yung mga cars pangdagdag. LiDAR, ano yung LiDAR? Laser detection and ranging. Okay. And ano tawag doon? Sound or ultrasound. Okay. So let's check. Wala pa, still busy. Meanwhile, may mga tanong kayo? Di pa tapos. Sorry, di pa tapos.
Gaan naman po so far.
Simple lang naman, By the way, guys, I strongly suggest you try out this software. Metashape by Agisoft. Same idea. So kung gusto niyo mag 3D ng mga objects sa paligid niyo, meron siyang 30-day free use. Okay? Yeah, imaginein mo, kunin mo ng picture yung mga mga heritage sites sa lugar nyo. And then load mo dito. It will use stereometry to estimate the 3D. Teka. Okay, and there's an educational license. We use this a lot sa research ko. Okay. So have a look at this, Agisoft's meta shape. Okay. So here's some video. Look at that. No? Pati yung mga pores kita. Okay. So these videos. All of these, but genetic engineers use this a lot. Silipin natin. Habang nag-load dyan, silipin natin. Wala pa, OMG. Busy pa rin. I'm sorry, guys. The script is still running. Kanina, mabilis to, ha? Siguro yung resources, inubos na. Anyway, I hope you can use this on your own and try it. Ito din. Loading din naman. Ubus na ba yung resources ko? Okay. Yan. Yan. Ang mga tipong ganyan, yung disparity. Disparity map. Okay. Alright. Again, those functions, those built-in functions, you just type them here and then search documentation. It will explain for you kung ano yung mga parameters na pwede mo pang gamitin. Okay? When you use it. And there are variations of these functions as well. Okay, I'm tired of waiting for this. Are there any questions? I'll just leave it to you to try this on your own. Again, remember, make sure that you do not use a plain flat object. Dapat marami siyang texture, okay, or picture. Okay, questions? Going once.
Ma'am, question po.
Yes.
Bawal po yung flat, no? Kahit na maraming color.
Ay, pwede.
Hindi,
So kung kunyari flat lang yung object mo pero tilted naman, tingnan mo tulad nitong aking laptop, makikita niya pa rin na palayo-palayo yung yung bandang likod, di ba? Okay lang na flat. Oo. Basta may mapaghahanapan siyang feature, di katulad nito na flat lang, no?
Opo. Tapos pwede rin po na flat pero marami naman pong color.
At saka
Considered as
tilted.
feature po yun.
Oo. Tapos tilted lang siya from your camera. Okay na yun. Parang na-reconstruct mo na yung 3D pag na-reconstruct mo or nakita mo doon sa disparity map na paiba-ibang kulay habang palayo, right?
Opo.
Halos depth map na yung disparity map no? Okay. Actually, nakita ko na to earlier kasi tinest ko to at boring lang naman to kasi almost all of these are not a number. Tapos dito lang banda yung meron siyang estimate ng disparity. So I enjoy you to try this on your own image and then that's the report, no? Okay. Okay. Other questions? Again, I assure you medyo boring lumabas dito kanina. Yeah?
Dapat po, ma'am, ma-maintain na horizontal yung camera, no?
Well, ideally, pero kahit hindi. Kasi kung kunyari medyo na-rotate mo, the fundamental matrix takes note of that. Remember, parang pinaghalo-halo siyang rotation, translation, scaling. Okay? So, kaya niya yan. Kahit medyo...
Kahit may konting tilt.
Dati nung nag-187 kami ginawa to, napaka-strict na requirement ko kasi wala ngang estimation ng fundamental matrix. So, I tell my students to slide along line yung camera, making sure it's not rotated. But if you can estimate the fundamental matrix, it's okay. All right?
Thank you, ma'am.
Okay. Other questions? Going once? Going twice? Kung wala na, sige, suspense tong natin, 3D image na iniintay. But sige, mas exciting siguro yun sa inyo kasi actually pangit yung lumabas kanina earlier. Okay? That's it for today. So next meeting, another 3D technique. Okay? Thank you. Yun na, nag-error na. Unresponsive. Graphics timeout occurred. Okay. Subuko. Sumuko si MATLAB online. Sorry about that, guys. Sige. Nag-work kanina. Ewan ko kung bakit hindi na-work. Ayun! Hey, guys! Teka, bago ako umalis, did you see this? Kita niyo to? Ito na siya. Ay, not this. Teka. Ayun, no? Kita niyo? Guys?
Yes,
You see
ma'am.
this? Oo. Again, wala siyang kitang matching points dito kasi flat. Tapos ito. Right. Ayan, no? Tignan nyo. Red is large disparity and may orange doon. Small disparity. And remember, inverse yan ha. 1 over disparity. So, ibig sabihin, tama naman. Yung orange, which is smaller disparity, mas malayo kaysa dito sa mga red. Oh, di ba? Ayos, di ba?
Okay. Gets.
Alright. Okay. So sana mas okay yung mga images na ano ha, makuha nyo. Katulad nito, nakalimutan ko. Sabi ko, keyboards. Kaya ito nasa harap ko. Alright guys. Thank you. That's it. Buti naman bago magsara. Yeah, you can see it. It's mostly not a number. Yun ang mangyayari dyan kapag tinignan nyo yung disparity map. Tingnan nyo to. Yan o. Anyway. Not a number karamihan dahil wala siya makita match doon sa pixel na yun. Okay? Okay. That's it. So, I'm excited for your 3D images. Sana maganda yung disparity map nyo. Good luck. Okay, I'll close this. No more questions. If meron pang maisip mamaya, i-message na lang. Okay, guys? So, kung wala na, see you again next meeting Wednesday for our second 3D imaging technique. Okay? Bye, guys. Ingat.
Bye, ma'am. Thank you
Kapit
po.
lang.
ma'am.
Kapit lang, guys. Kapit
Thank you,
lang.
ma'am. Ingat po.
Okay. Sige.
Amen.
Bye.